Okay.
Great. So hi, everyone. Welcome back to another cohort call of Open Hour Makers. We are on week 11. That means we're really pretty close to the end, which is quite exciting. And week 11 is all about licenses and standards, which is, as I was saying before the call was recorded, it's a heavy topic for open hardware projects, but it's a very important one. So we intend this to be very soft introduction to the topic, so you know where to look at and how to find further help if you need for your open hardware project. So as I was saying, this is week 11 and we are doing some peer review because this topic started last week. You can find, of course, all the materials in our curriculum. The previous 2 weeks, I was not here, but on week 9, you have been talking about in the cohort call about road mapping and the process of envisioning the future and planning the future in more concrete steps backwards for your project. And 2 very crucial aspects of every project, I would say every project management, but you can really suffer if you don't do it for your hardware project, which is managing time and evaluating the risks. So being aware of those maybe non-technical aspects that will determine if it works or not. And in the next week, with 10, that was just the week before this one, you probably started taking a look at the model number 6, which is licenses and standards. And we are super aware that this is a lot of information, and we are trying to digest it in this cohort calls for you to have a glance at it, and maybe when you have more time, you can dive into the curriculum materials on your own. If you go to the curriculum, you will see that this module, yeah, that's fine. This module starts talking about how do licenses work, which is a very basic but very important concept you need to have in mind, because we start mixing ourselves with patents, copyright, licenses, what's going on, and we should have this clear in order to make sure that we're using the right instrument. It continues talking about which are the available licenses and how they are different, and giving you some hints of which are the main elements of a license that you should consider when choosing one. And then we go to a different topic, but quite related, which is standards. So as you know, open hardware has been around for a while. And if you have been digging into the community, you will probably learn that there are thousands of projects, platforms. It's really difficult to find stuff. So people in the community have been working on findability standards and very intensely also in documentation standards. So how to structure your documentation, and there are different options there for your project. So we'll talk about that today. The agenda is we'll give you an overview of licensing, how it works, which options you have, where to start looking, basically. We will move then to standards both for documentation and for findability, and we will have some discussions around, okay, this is great, but how do I apply this to my project, and why does it matter? So I will now pass to Alex, and we will both complement each other today, licenses and standards.
Yes, because one of the main reasons for that is that we both are no lawyers, obviously, and we have different focuses and foci in our lives. And what we are trying to do is we want to give you an overview, as Juli already said. And there are probably more things we could talk a lot more about, like more details and pros and cons of certain licenses. But instead, we will just like keep it on the surface, and you have a lot of material resources in the respective element in the curriculum. I think this is the licenses and standards part, is the part of our curriculum with the most resources. So please go there. And we also shared some in the document you are currently having open, hopefully, at the moment. So yeah, okay. Licenses, patents, and how does it work? So you probably will often hear, well, if I don't, I want to keep the idea. I have a great idea. I want to keep this idea for myself because if I talk about it, if I put it into the open, then well, somebody will steal it and just use it for themselves and make money from it. This is something we hear quite often, and it's not like that true. I mean, I'm coming from a scientific field, Huli, you too, and there's always also the fear about being scooped, that you have an idea and you don't publish about it, and then somebody else comes up with the same idea, or basically, well, robs you of the whatever your findings you had. And it's similar with the open hardware world, but except that it really does not work like that. Because, for example, for patents, as far as I know, it's important that something is novel and has not been described. So actually being open from the very beginning is the best thing to actually avoid to have something being patented or stolen by somebody else. Because actually the best thing is that you put something online and that you can prove that it is online, that you shared it and that you had the idea basically first. That's usually something you have to prove. And what could be easier than just showing it the whole world by putting it into the open. So that's why we object patents in general, because patents also slow down, in our opinion, for at least for the examples we have, slows down innovation. We put down the complete story about 3D printing in our curriculum. I briefly want to summarize it as that when the concept of 3D printing, the FDM printing, came up in the very beginning, the printers were really expensive because everything was protected by a patent. But it was just then when the patent expired and open source communities picked it up, like the RepRap community, and then developed cost-effective 3D printers, versions of like the concept. And now we have like sister projects like Prusa, which sells so many 3D printers. That's one part. And also 3D printing became really affordable for basically anybody. It's another question if 3D printing will solve all the problems in the world. I guess not, but at least this actually made this technology accessible to like basically almost everybody, right? So this is just an example on how a patent completely restricted innovation or spread of a technology into various fields. And yeah, we are, I think, also profiting a lot from this expired patent now.
Yeah, and just FYI, and you can learn more about this in the Open Source Hardware Association's website and also in a study that I will put the link in our notes. Please go to a section that is there called resources. What you protect in hardware, patents apply to material stuff, but what you're protecting with the license is the design, right? So it's talking about copyright, in fact, because you're protecting the design. So if your design is patentable, is something that can be protected or not by the license, it's not a question that is just, you can say yes or no, very straightforward. You have to understand where in the range of more protectable and or less protectable it falls. I may be speaking in Chinese right now, or in a language that you don't understand. In my case, it's Chinese. But if you go, I just wanted to leave this website here because I think it really explains this very well. I leave the link in the chat. Per se, their functionality is not protected by these licenses because most of them, the functionality is very generic and already exists, as Alex mentioned, everywhere, right? So the more different your design is, the more personalized and customized is, you can protect it. It's more that you can protect openly by the license. So this is not a question again of yes or no. You have to carefully evaluate where you fall in this spectrum. And if you go to this link I sent in the chat, you have different examples of open hardware projects and where they fall. So maybe you can understand where yours fits.
So licenses and patents are completely two different things. Also a patent, like a project with a patent might have a license as well. But anyways, let's talk a bit more about license in general. Because
you can also protect your brand. That's also like a trademark, which is what Arduino does, for example. But yeah, there are thousands of options. The website I just sent you is pretty straightforward if you go into it.
What we want to talk about now are the elements of a license. Yeah, I will just quickly go through them. It's attribution. Attribution means like if I use parts of the project, how should I make it visible that I used this part? Meaning like that you reference. I use this from Open Hardware Makers, for example. So use areas means, so for what does it apply? So is it actually the code? Is it the hardware design? Is it the documentation? The elements of a license also mean like how is commercialization? No, sorry. Commercialization is allowed, because you probably already saw licenses which allow use, reuse, open reuse, but not in a commercial context. And a license also should have a component which says how derivatives can be formed and how they should be treated. And we will talk a bit more about that and what this actually means later. So about the attribution. So usually what I really like are the CC licenses, because they make it really easy, because it has this different things, the attribution. So what do you want? A CC0 license, for example, does not need any attribution. So if we put our curriculum out into the wild, we could say, okay, it's a CC0 license, and everybody could use it without telling anybody that they used it from us. So it's just not allowed that you say, okay, that's mine. I did that. So this would be a bit unfair, but you could use it without referencing us at all. Then there is the other option, obviously. If you have no attribution, then you have attribution. And this is, for example, how we also published our curriculum. So usually if you use our curriculum, you should put somewhere, this is the curriculum of Open Hardware Makers. This is meant with attribution. I will skip the use areas for now, but I want to talk more about the commercialization, because this is also easy explained with the CC licenses, because you have the option to have something restricted, so it's not allowed to use it in a commercial context. So is NC, so non-commercial. But there is a twist to it, because and it's the general thinking in the open hardware community, that an open hardware project, if it to be really open, it should also include it should allow commercialization. Sorry. And so that's why we think that this should be always allowed, and that's also what we recommend you to include in your license. So
in fact, it's not open if it doesn't allow commercialization. So be aware that, for example, if you want, we will see later, if you want to certify OSHA and you don't allow commercialization, it's not open. You will be rejected.
And then now I'm into this language hole again. So if you want to build something, if you see a project and you want to reuse things, so how should you, what should you do? How do you have to license your build if you build upon another project? That's also handled by the license. For example, the CC license have share alike. So you should share it as the first version of the project was shared, just as an example. There are different variants of that, and that's what we want to talk about more when we talk about copy left and copy right. I don't know if you or copy left or not copy left, because we are not talking about copyright today, obviously. But copy left is basically almost like it's more than the opposite of copyright, because copy left is like basically a pyramid scheme of open hardware, because if you can write into the license that the project which built upon your project should also have the same license. So the license basically spreads like a virus, and if you have a lot of derivatives, people who build on your project, the license will spread with this new forked projects. So how does licensing now work for hardware projects? That's an important question, because I now just talked a bit about like the general elements of a license, but what's the implication for hardware projects? That's something we write a bit more about on our curriculum as well, because usually you need multiple licenses for your open hardware projects, because it contains different parts. It's a different story with open software projects. They usually have only one license, but might also have multiple licenses. So for hardware projects, we have, for example, the documentation, which should have an own license. We have the hardware design itself, which should have its own license, and so on. So what you usually do, when you add a license to your projects, and you can download one, for example, and just add it as a text file to your repository or wherever your project is hosted, and then you can add what it applies to. So I'm just giving you an example. For my projects, if I have a documentation, and I usually have a documentation folder where I then put a license document in there, and also write that it applies to the documentation. Documentation licenses are, for example, the CC licenses. I like them very much, and that's why I'm also recommending them to you. You find the link to them in our curriculum. Please take a look at what suits your project. But now about the more tricky part, about the hardware itself. Luckily, there is CERN, and CERN has its own, let's say, open hardware license, and there is now a second version of it, which is a huge improvement in my opinion, and I really like it, and I use it also for my projects, and we highly recommend you to take a look at it. There are different versions of it. Some are more permissive and some are less permissive. That's what their main distinction is. And you can choose which one you like, and you can also just download it, copy it, and add it as a text file to your repository or the place where you store your hardware designs. All right, there are other hardware licenses. I think the MIT license also could be used.
There are some background there is that these are the three recommended by OSHWA, by the Open Source Hardware Association, and Solderpad was a non-copyleft version, kind of, if you are familiar with software, kind of similar to the Apache license in software. But the new version of the CERN license is more, I think it aims to be like the hardware license people use, because it incorporates comments from the author of the Solderpad. And now you have like a comprehensive suite of licenses within the CERN open hardware license, in which you can use, okay, more permissive, less permissive. I think it's important there to think of what's your idea. Do you want your project to be quickly adopted by anyone? I think this is very reminding us of the conversations between GPL and MIT licenses in software world. So if you're familiar with those discussions, it's kind of the same.
Yeah, and you should really like take a look at what do you want? What's the purpose for you? And yeah, actually ask yourself that. But what you also have to do, and now we are back at copy left, take a look if you're using some things, some parts of a different open hardware project, take a look what they are using, which license they are having for their hardware designs or documentation. And maybe they have also a copy left license. So you actually don't have a choice, but you have to use, at least for the parts you incorporated, you have to use the same license. Then
and this
again.
is important also because as you start to pay attention to other people's choice of licenses, you can avoid the very normal, very frequent problem that people have, which is, oh, I found this great project online, and then I take it and I reproduce it and change whatever I want to change. And when I want to now make it a product or whatever, I realize that it has a non-commercial license. All this work for nothing, right? So two things: be very aware of the kind of license that projects have when you're going to reuse them, and let's try to discourage the non-commercial licenses because they are a pain. And that's it.
All right. Okay, so I don't know. I think actually we can somewhat recommend, please, Juliet, keep me away from that. But I would actually recommend the CERN license for now, the second version now. If you don't have any clue and if you want to have one starting point, I'd say please take a look at the CERN 2 licenses.
Yeah, I think the new version of the CERN one is pretty good. It's kind of the de facto standard. It's becoming the de facto standard in the community, right? But also, I just added in the notes under the extra resources 2 links, and the second link goes to a publication for the European Commission that's what was written on open hardware licenses. It's a lot of text, but you don't have to, of course you can read it all, but it has a very interesting chart that compares different elements across the licenses. And it also has a section on implications of choosing different licenses, which I think is really good if you are trying to make your choice. It's really good to read if you're trying to make the choice. But I think the most relevant, if you're not very sure, I think the CERN one gives you a couple of options to choose from that are interesting.
Yeah. So takeaway messages are, well, take a look at the different licenses, make sure you have a license, maybe rethink your choice for a license. And please keep in mind that you probably need 2 licenses, one for your documentation and all the software you used, you wrote, and also for your hardware stuff, like mechanics, cut designs, and so on and so on.
Yeah, we usually tell, you will find that in the curriculum, that in general, using 3 licenses, documentation, software, if your project has software, and hardware is the way to go. And that will make your life easier if you're trying to go for OSHA certification too in the future.
And that's what we recommend. Go for the OSHA certification, but to that later. Now we want to have, well, a bit of a conversation with you. As always, you can also add comments in the document, you know that. So, but what we want to know is what's the best license for your project? So, and we have here 2 questions for the discussion. So which are your goals and how do they align with the available options? So attribution, copyleft, non-copyleft, and so on. And which license for which components. And just take a look at choosealicense.com. I think the link is also in the doc, but it's also not too complicated to write. So please just take a look at it. And I'd say we do like 2 minutes silence, and you can have a look at everything, and then let's talk a bit, and let's start the discussion, and well, share your opinion or your questions also, or your problems, the things you need to overcome or whatever.
Yeah, also if you had any experience up to now, if you tried to apply any license, and if you found, or if you think licenses are not relevant, honestly, for you, why not? Have you had problems with other projects' licenses? Let us know what you think. I think we can give you 5 minutes to explore the website
5
of
minutes?
Choose a License.
Okay.
And we come back.
Okay, then 5 minutes. All right.
Let's pause. I will be. And we're back, and you were talking about standards and why OSHA certification was worth it. And I was just saying that if you follow the curriculum and do all the assignments and everything, it shouldn't be that hard afterwards to go for a certification.
Yeah, because who decides if it's open hardware or not? In the end, we have the standards of OSHA to clarify this. And yeah, but we also want to introduce something else for the people who are more interested in building, well, something on an industry level, or yeah, well, I don't know, like also in the commercial sector, maybe this is also more relevant, because there is now a DIN specification 3105, which is an open hardware specification. So it tells you a lot about what has to be in the documentation. It mainly focuses about on documentation. And it tells you what needs to be there. So what drawings and so on, what's necessary. And then you can get an official certificate, like a DIN certificate for your project, that you can officially call it, well, open hardware project, also in an industrial context. They developed it because they wanted that it gets more traction also in the industry. I don't know if it's mainly a German thing, but it was developed by the Open Source Ecology Germany as parts of it. And there were many people involved. Also Mo, which was also a guest speaker some time ago, he was heavily involved there as well. And I think it's a really great piece of a standard. It's for my taste, for my personal, sometimes really simple open hardware projects, it's a bit too heavy. It focuses a lot on mechanics, actually. But it's really a really good and nice thing. And if you want to go into the industry direction, so this is something we highly recommend you to take a look at. I'm thinking maybe of, for example, Blue Grease or something like this.
Also, I don't know if any of you is in Germany, but this event is happening around open hardware and product design. So
I'm looking for
we highly recommend you to go if you are around. And this is the people who are in charge of the DIN standard, which I know it's a thing in Germany, but also apparently is quite of a reference in some other countries. So if you are looking towards an industrial pathway, that is the way to go.
And I also will be at the event, so you get to meet me in person if you want. I will copy the link. It's happening in Berlin, and it's happening on June 29. Yeah, I posted it. Yeah, if you are around, then come over and visit. Okay. Take a look at this, at the standards, at the documentation standards. Yeah, to sum it up, to wrap it up there, please, we highly recommend you to do the OSHA certificate process when you are done with this, with open hardware makers. We highly recommend it to you.
And if you need help with that, just let us know. We understand that it may seem like a lot of work, but it will be also interesting for us to understand which are the bottlenecks, or which are the problems that you find with the certification, and how our program is helping you on that or not. So it will be great for us to hear back on this from you. All right, shall we move to the next?
Do you want to talk a bit more about findability, Juli?
Sure. So I think yeah,
Ah,
there we are. So we were talking about this too. And now we're going to move about to findability. So findability is, I think it's a very understandable, it's addressing a very understandable problem for anyone who has been interacting with open hardware in general, because it's a pain to find stuff. There are so many platforms, there are so many different projects, and one could dream of a search engine of open hardware, right? So the idea behind the open know-how standard and the library of open source data, with which I'm not very familiar with that one, so I may ask you for help there, Alex. But it was designed by the same people we were talking about recently in Germany. Behind the open know-how standard is to provide people with a very, very easy way of indexing their open hardware projects. So if your project is in whatever platform, GitHub, GitLab, Wikifactory, Instructables, whatever platform you want, the idea is that you add a file to your repository, and this file is called a manifest. And this manifest is basically a YAML that has, YAML is a format, it's a text-based format in which you add values to different variables in this index. So from which tools are you using, or is this related to any community, or which are the sustainable development goals associated with this project. All that information, once you upload it in the manifest, becomes searchable. And then you can go to the search engine of Open Know-how. I don't know if you have the link somewhere, Alex, if you can paste it there. It's not that one. It's search, I think it's search.openknowhow. In fact, yeah, it's search.openknowhow.org. I will put it here. Then you can access all the projects that are using this manifest. Doesn't matter which platform they're in. And this is great, not only because it's an easy way of finding projects, but also provides much more information than just a design, right? It's providing lots of meta information that currently we're missing. So we highly recommend you to take a look at Open Know-how. There are also, I think, flavors of Open Know-how, and the library of open source data is using one of those. And you can go to lush.opennext.eu, and I think it's using kind of the similar system, again, a manifest, but in a different format. I'm not sure I understand very well the differences. So Alex, if you know, please go ahead.
Yeah, you can take a look at our recordings, because Mo was actually introducing this. So he was working on the OpenNext project, and he was responsible for building it, as far as I understood it. And he is giving a short show off of the LOSH, the Library of Open Source Hardware, and explains a bit.
I missed it.
And yeah, absolutely no worries about that. But that's where he also explains that they are now improving it and so on. And they want, yeah, to include more projects also, let's say, involuntarily. So you don't necessarily lead a manifest, but for now, if you want it to be added and it's on GitHub, for example, you still need a manifest, because obviously there are so many GitHub projects out there. And what they are doing is they have a data crawler which crawls everywhere on the platforms they add. And they are still working on it, and they still have to improve it. But what they also implemented now is a support for YouTube, actually, which is super interesting, because many people look there first for finding solutions for projects. And it would be great to also, well, link more videos of open hardware projects into a library. Right, but in general, I actually talked to the people just right before the call. So one person was also involved there in general with the projects, and these two projects are known in the community, in the open hardware community, but not really well outside. So still, what we always recommend you beyond now this findability standards is that you can always have your base repository, which doesn't have to be in GitHub, but can be also on Wikifactory, on whatever platform you choose. But what you can then do is you can put it also on other platform and link it. So you have one mother platform, let's say, where you keep it, your base, and then you spread it. And there are, for
or
example,
a website.
Or yeah,
a website usually works great, especially if your main repository is GitHub based or Git based. Even a simple one-page Jekyll or Hugo website will help you a lot. If your project is bigger, a community forum makes a lot of sense. And we'll talk about that in the next cohort call.
Yes, we will talk. Yeah, exactly. This is now on the edge, and it's also a good transition now to also community and communication, because that gets more and more important then. But there are also other platforms, like, for example, Instructables, like also Hackstar, Hackaday, and so on, which have a bigger popularity, let's say, and attract a completely different kind of like people who might discover your project there. All right, but
just
I don't want.
Sorry, as we were talking about platforms, website. We had really good experience with Mira Haze. It's, I think, the only not-for-profit freely hosted Wikimedia, and it's been really working well.
Awesome. Thanks for sharing.
Can you link that in the chat?
It's in the chat already. Thank you.
Oh, okay. Thank you.
There's another question. Do you know any good tools to spread information from a single source of truth to different platforms?
The question. You mean any good tools in terms of easily copying the information in your repository to other platforms? That's what you mean?
Like that you have it, yeah, automated, yeah, that you have it on GitHub, and if you have changes in GitHub, that it pushes it everywhere. Like, no.
No, I know about Git building,
yeah,
which is a good place to merge website with Git. Gitbuilding.io, but it won't do exactly that. No, that is a problem. But in fact, if you add an open know-how manifest, you kind of appear in this search engine. But I don't think there is a tool right now to automate copy pasting to like viral.
Unfortunately, this is, well, this is something maybe at some point somebody will try to work on something like this. What we recommend is just have your base, and this is where you keep most of the information. And on the other platforms, just have pictures and not the up-to-date maybe versions, but then link always back to the mother project, let's say. Okay, we wanted to have a small, short discussion about which standards you find useful and which standards can contribute to your project. But I think we have to. And I
think we've been doing that in this Q&A in the chat.
I have a question though about the OSHPA certification. You were quite passionate about it. So what are the major advantages that you see about it?
You're gonna go?
So the major advantages, well, let's say what not the advantages are just for yourself. I think if, like in the first place are for yourself, because you reflect on your project, you go basically through a list and you have things you can check or see, I have to still work on that. That's the one part. And then the other part is you can, for example, then add the open hardware logo on your project, whatever, wherever you want to put it. Obviously, you can just copy it and put it somewhere, and probably nobody will blame you. But with the certificate,
I think they give you a code, right? They give you like a registration number.
Yes, so you can reference that, and it's properly certified. So you know you did it like really?
I think it depends on who you're talking to. Who is your audience? For example, if you are in an academic context, maybe it's not relevant for you. But if you're trying to look for funding or like try to show that your project is being serious and legitimate, then it will kind of help you. If you see who is certified, you can access a list of certified projects, and most of them are from Adafruit, Spark Fund, like the big players. But many others are not, and I think it depends. I will be absolutely honest. In some contexts, it doesn't make much sense because people do not pay attention to it. But in other contexts, it's quite of a difference, especially if you're trying, for example, to engage with, I don't know, a manufacturer or someone who wants to trust that your design is well documented. In that case, then it's useful.
I can imagine that for your project, Simon, the Blue Grease project, this is like a really good selling point that you say, well, our project is officially certified by OSHWA and is open hardware.
Yeah, I think it's really interesting. Also, then we can engage with scientists and show them, okay, we are, and also with like small companies, perhaps. Yeah, I think we'll give it a deeper look there. Thank you.
And yeah, please, for your project as well, take also a look at the DIN spec. I mean, it will look a bit heavy. I also shared the mechanical documentation standards from the OHO, the Open Hardware Observatory. So many different expression and names. Sorry about that. I put it also in our meeting document, so you can take a look at it at some other point. It has a lot of details, And
maybe maybe it's good for a second stage.
Exactly.
The DIN one.
All right. Let's wrap it up. Thank you for joining, and we will stay a few minutes after the call in the room. So if you have any questions, let's just stay here, like general questions. But what you should have made sure is that you have your meeting scheduled with your mentor next week. There is no cohort call next week. We will see each other on June 15th. Well, as you know, check your emails on Monday. You will receive them as usual, and there will be the outline for community and communications there. If there's something you want to talk to us about, then just write us an email, contact us in any way, write us in the Gosh forum, whatever. Stay in the call.
Yeah, and there's an important, next slide is important before we close, which is the final demo call is approaching. We are on week 11 and this program has 16 weeks. So we are let's say a month away from the public call. This is the time to start thinking of your demo.
And we see this demo also as a chance for you to prepare basically a small pitch, because we will record it and then we will also chop it into pieces so you can get your video pitch and incorporate it, for example, in your documentation, in your wiki and so on, and use it and share it. So this is the place where you can also show others and the greater public.
We will live stream it also. And I added something there that just I think it's interesting. If you would like to invite someone to the call just for a discussion on your project afterwards, we are open to that. So if you think you would like some particular person from a community or from a project to be there to listen, we can specifically target that person. So the person is aware that this is happening. So let us know. Let us know in advance so we can focus on that. But think of your demo. Think of something between 3 and 4 minutes max. Think of incorporate. You can do it in whatever style you want, but of course, if you show some hardware, it will be more interesting. But this program is a lot about documentation, so make sure that your documentation is on point and you can give us a link to where it is. Discuss it with your mentor next time. And I think that's it, right?
That's it. Thank you very much for joining.
Yeah,
a
let
nice
us
day.
know. Yeah, let us know if you have any questions. We can stay here.
Otherwise, you are free to leave.
I will stop the recording if that's okay.
Yes. Nano also did not leave.
Yeah.